Hello everyone, it's me again, Omar Zulkarnain, and now we are in the part 2 of our presentation. So what we are about to present now is the second part, which is the explanation. So we are going to explain about the explanation. Seems a little bit funny, sounds a little bit funny, but don't worry, you will understand more and it will be more clear for you after this. So without further ado, let's proceed into the content of this part 2 of our presentation. So the first one is we have the definition of explanation. Second, we have the good explanation. Third, we have the model of explanation. And fourth, we have types of explanation. Fifth, we have ways of explanation. And the last one, we have facts, hypothesis, theory, and law in explanation. So I will go to the first one and I will explain and brief you guys about the first one, which is the definition of explanation. So what is explanation? So explanation is defined by a set of statements that is usually constructed to describe a set of facts which clarifies the cause and understand context and consequences of other facts. So that is the simple definition of explanation, and we can actually develop an explanation. One of the simple concepts is to use questioning based on our observation. When we see something, when we look at something, we question with why or what, where, when, or even how does it happen, why it happened, what makes it happen. So that is one of the concepts. But don't worry, I will guide you through a better development of explanation. So moving on to the next slide. To develop an explanation, there are 5 steps in developing an explanation. The first one is to engaging in scientifically oriented questions. The second one is to giving priority to evidence. Third is to formulating explanations from evidence. Fourth is to connecting explanations to scientific knowledge. And the last one is to communicating and justifying explanations. So I think it will be more clear and it will easy to understand if we give an example, right? So now I'm going to proceed with an example, and I want you guys to focus because we might have some activities after this, right? So this is an example of explanation in a situation of why do different objects falls at different speed. So I believe that most of us have encountered this situation. Sometimes we see a leaf fall from the tree very slow, but sometimes and at other times we can see that perhaps durian or perhaps apple falls from the trees at a very high speed. I believe that most of us have encountered this situation. So based on this situation, I want to show you guys how to develop an explanation. So the first one, just like I said before in the previous slide, is to engaging in scientifically oriented questions. So the first one I put there is questioning. Is it because of the weight? Is it because of the gravity? Or does it relate with where it falls? So we question based on scientifically oriented question. Is it because of this and that and so on? Why, what, where? You can use any points you want, right? That's the first thing, questioning. Second, we are trying to give priority to evidence. Is it because of the weight? The weight influences the object and hence it makes the object moves at a higher speed compared to leaf, which is very light, so it will fall at a very slow rate of speed. So we are giving priority to evidence based on our questioning. Then the third one is formulating explanations from evidence. So in this part, I put the developed theory. So perhaps it's because of the air resistance or the weight. So we can put a theory, or we make a theory based on our evidence that we think and based on our questioning. Does the air resistance affects the speed of the object to fall? Does the weight of the object affects the speed of the object to fall? Theories that we develop will play a very important role in us explaining something, right? So if we focus on, let's say in this context, we are developing the theory of air resistance. So does the air resistance affects the speed of the object falling from its place to the ground? Because we know that every object falls at the same speed because of the gravitational force. So in this concept, we are trying to use the air resistance theory. Next is to relate theory with knowledge. We know that there are experiments that involve this concept of objects falling but without any air resistance, which is the vacuum experiment. So we try to relate the theory that we develop with the knowledge that are based on scientific knowledge. So in this concept, we can say that the vacuum experiment shows that objects fall at the same speed when there is no presence of air. This means that the reason of the different speed is because of air resistance. Try to relate the theory with the knowledge that we gain and possess and so on. Right. After that, we try to create an explanation based on the observation that we get, based on the questionnaire we get, based on the theory, and based on the knowledge that we relate with the theory. So our explanation will be air resistance is greater when there is bigger surface of the object. So comparing leaf with coins perhaps, or apples or durians or any objects that you want, leaf will fall slower because of the air resistance that act on the object. That is an example of how explanation is developed. Some of you guys might still under a little bit of confusion, but it's okay. You guys will understand better, and you guys will be exposed with more and a better understanding of the concept of explanation. And now we are moving on to the next part of the explanations, which is the good explanation.
So I'm going to explain about good explanation and model of explanation. So what is a good explanation and how we can find out? According to philosophers of science, they have traditionally answered this question by concentrating on the norms governing scientists' explanatory practice, evaluating these norms on the basis of their intuitions on a battery of cases involving putative explanations. Starting with the work of Carl G. Hempel in the 1960s, philosophers of science have articulated three main models. Let's get to know what are the three main models. So the first model is covering law model. According to covering law model, explanations are arguments demonstrating that what is being explained logically follows from some general law. So it was founded by Carl Hempel, who was an American philosopher. He argued that explanation should be restored as one of the aims of the sciences. First, explanation should give ground for expecting the phenomenon to be explained. Second, explanation should do this by making apparent how phenomenon exemplifies the law of natures. Explanations are arguments. The conclusion of the argument is a statement describing the phenomenon to be explained. The simplest type of explanation is that in which the conclusion describes a fact or event and the premises provide deductive grounds for it. Okay, the example is, by covering the law, if one asks why does a flagpole cast a shadow that is 10 meters long, the explanation should cite the law of optics, the height of flagpole, and the angle of the sun in the sky. The premises will constitute an explanation because the conclusion follows from them deductively. So this flagpole casts a shadow that is 10 meters long will be the conclusion from those premises. So let's move to the next model. Unificationist model. Unificationist model says that good explanation provide a unified account that can be comprehensively applied to many different phenomena. It was founded by Philip Kitcher, who was an Australian philosopher. His doctor advisor, Carl Hempel, who founded the covering law model previously I explained. Kitchen wants to improvise the Hampel's model by not focusing on highly kind of understanding only, but also on the insight that is achieved by a systematic unification, by exhibiting the phenomena as manifestation. The unifying power of Newton's theory and Darwin's theory consisted in its demonstration that one pattern of argument could be used again and again in the derivation of a wide range of accepted sentences, which means this theory appealed again and again to a few basic principles that can account for many great phenomena. So let's move to the example. Newton's law proved that apples take many seconds to fall from a tree of such height. Okay, Newton showed that you could prove this by setting up a differential equation governing the apple's motion, use his three laws and the law of universal gravitation, and then solve that equation. You want to prove some facts about the moon's orbit? You can prove them using the same method. Next, Darwin's theory. Evolution of organization. Darwin proposed that species can change over time, that new species come from pre-existing species, and that all species share a common ancestor. Second, nature of selection, which is specifically for plants and animals. It explains that the fittest will survive and the weak will die. People outcome with social Darwinism, specifically for humans, the rich people are the fittest, will survive, and the poor are the weakest, so that they should be left to die instead of being helped. So according to this Kitchen's model, that's what it is for Newton's theory and Darwin's law to unify all these phenomena. So let's move to the last model, which is causal mechanical model. Causal comes from word cause, which means reason. So basically, we need reason for something that had happened. According to causal mechanical model, the explanation which reveal organized component parts and activities that make things happen. It was founded by Wesley Charles Salmon, who was an American philosopher. Salmon said that causality plays a central and fundamental role in scientific explanation, and he found causality all over in scientific explanation, which is not identifying only natural laws, but accounts for them via nature's structure, and thereby involve the concerning reality, how the phenomenon fits into the causal nexus of the world. The causal nexus means bonding or link between cause and effect. Salmon also finds scientific explanation to be not merely nomological, that is law-like, but rather causal or mechanical. Though asserting the primary of causal or mechanical explanation, Salmon was vague as to how scientists can attain it. So basically, this model says that if something happened, we need to find reason not just based on law-like, but through the activity or some component parts that make the things happen. So let's move to the example to help you gain better understanding. So the first example is in the case of lung cancer. Scientific analysis of cigarette smoke have shown that at least 70% of chemicals present in the cigarette smoke will cause cancer in laboratory. This established a causal link between the component parts in the smoke with cancer. Second, the causal mechanism for opening a door is the turning of the knob and exertion of pressure on the door. Opening the door is relating to the activity so that the door will be open. So, I'll pass the presentation to the next presenter.